no ads, earlier content, ask me questions, and even get a Discord call with me to help with your game. These are all on my Patreon right now. Content warning. If you're new to the Unreal Engine, this is going to be very confusing, but I do not want to demotivate you. You're not going to be able to get this video in one go. You're going to need to do it a couple times to fully grasp it, or at least do this exercise multiple times, even if it's not viewing this specific video. But if you're exhausted and confused by the end, I'm sorry, but it is the nature of this complicated topic. Hello everybody and welcome back to the basics of artificial intelligence in the Unreal Engine. If you remember last time, we made it so our AI can successfully navigate its area by having a nav mesh, which basically tells the AI places that it can actually reach, as well as the AI being able to grab a random location and tell itself to move there, as you are seeing right now. The model's sliding. We're not here for animation training. We are here for artificial intelligence training. Today we're going to make the AI a little bit smarter. We're gonna have it make decisions based on things around it. So something I like to do whenever I am working with AI is I like to create a little stage for it to work off of. So I'm going to use the cube grid to create a small little area for the AI to actually do its decision making in. If you'd like to follow along, please do so now. Okay, as you can see, I've got a little area for us to start on up top so we can very easily look down and see what the AI is doing. And then we have a little platform for it to be on, as well as the nav mesh for the platform. And you'll note that everything just disappeared. This is a bug that happens in Unreal Engine. I find it very frustrating. The only thing that I've been able to do to fix this issue is if you scroll down, you'll see that the cube grid that we just created is unloaded. The only way I know how to fix the issue is to save the project, go up to build, and then just click build all levels. I just delete the HLODs and then I save the selected, and that's how I handle it. If you can think of another way to solve this, or you do know the way to solve this, leave me a comment. I would love to know, and I'm sure others would love to know as well. I'll be back when this is done. When it's done, your object should come back, and you might have this world partition here. Sorry, that was a little bit of a side tangent, but it does happen, so it's good to know how to fix it. Anyway, as I said, we have a stage and everything. So what decision do we want our AI to make? Well, in my opinion, what we should do is we should have the AI pretty frequently move around the platform, so that way it has more chance of getting where we want it to go. But when it approaches a door and actually interacts or gets close enough to the door, we should have it then decide to open the door. Now, obviously, that logic is only for a beginner, because we would want the AI normally to only open the door if it needed to go through. But from a beginner standpoint, let's figure out how we get the AI to communicate with the door so that it opens up. In order to do this, we're gonna have to make a basic door. So in your content folder, I'm gonna create an additional folder here and just call it blueprints. I'm gonna open that up. We're gonna create an additional folder, and we're gonna call this actors. And I'm gonna go open that up, create one more folder, and call it doors. Now, this might seem like a lot, but getting your folder structure solidified early is always important when it comes to creating really large projects. Just trust me on this, or you will get burned. And some of you need to get burned to learn, and that's just the way that it is. But within that doors folder, we're gonna go into the blueprint class. We're gonna go up to the actor. We're gonna call this BP underscore door one. Why am I calling it door one? Well, later on, I might create additional doors, and we don't want just BP underscore door. I'm gonna go ahead and bring this tab to the top, and all we're gonna need is two things. We need a static mesh, which I'm gonna call SM underscore door, and then we're gonna need some box collision. So just type in the word box, click on the word collision, and right now you'll see that box collision is actually a child of SM door. If yours did this as well, go ahead and drag box to the default scene root. Do not click make new root, just go ahead and hit attach, as we want the door and the box to not have that parent-to-child relationship. Now, I'm gonna click on the SM door, and I'm just gonna use the default door that comes with the Unreal Engine. So with SM door selected, on the right-hand side in the details panel, you'll see an area called static mesh. We're gonna go ahead and open that up, and I'm gonna type in the word door. For some reason, I'm realizing I don't have the starter content. I must have accidentally made this project without the starter content. You can use the default door, but I won't be able to. Let me go grab a door and I'll be right back. I lied. I'm gonna show you how I'm gonna do it, so that way if you ever need a door or whatever mesh from the cube grid, you can do it as well. I'm gonna go to the cube grid. We're gonna do a door which does not need to be that thick, so we're gonna drop the grid power down to 3. And I'm just gonna go ahead and just like click here, go over to roughly door size. Normally I would highly recommend doing it near your AI. So something like this. So that way you know how big the door should be. Obviously the door should be wide enough that no one struggles when they're standing with their arms down to get through. So something like that, but obviously not large enough that if their arms were extended, they would hit the walls. So I'm gonna go ahead and start building up that door. And obviously we want that to be a couple notches taller than the mesh. So that'll be our door for now. I'm gonna hit accept. And you'll note that in the outliner, it's just named Cube Grid Tool, but if I change this to SM Door 1, that if we were to go back to here and search in our static meshes for SM_door, it doesn't appear. And the reason for that is that this door, even though we changed the name over here in the outliner, it didn't change it in the actual contents folder. What we're gonna do is right here where it says static mesh, and you can see that it's got the mesh selected, click on this browse to cube grid button, and you'll see that here is the actual file for that door that we created. So here is where I'm gonna change it. I'm gonna call this SM Door 01. In fact, it's very good to start naming your cube grid stuff in a way that you can access it again, so you're not just filling your content folder with a ton of unnecessary cube grid files, increasing the size of your game unnecessarily. And in fact, sticking with that theme, let's go ahead and rename this to SM AI Staging, or whatever you want to call it. Some people will even do SM_CG_ then the name, and then that CG stands for cube grid. It continues to diversify that file from something else. In this case, I'm just going to use the SM. However, do note that the CG does help. With that created, we can head over here, and now when I type in SM_, I can start typing in the word door, and there's the door that we created. So you'll see here that it starts with a default rotation of 0, 0, 0. You'll see that its location 0, 0, 0. And luckily, its default anchor point is this corner. And the reason I say luckily is because when we rotate, we want it to rotate on that axis. If it didn't, what would happen is this door would rotate from the center and it wouldn't actually open. And to be honest, as you can see here, it's still not rotating perfectly, because the rotation is on this corner here instead of the center where the hinges would normally be for a door. That being said, this is a tutorial about AI and not doors, so we're going to accept that as a loss and just deal with the fact that it does that, because we're not here to make a perfect door. Now what I'm going to do is I'm going to move our box to roughly the center of the door. So something like that, and I'm gonna increase the box extents to probably around 200 in each direction. So something like that. Whenever the AI enters that box, we are going to send a signal to the door and have the AI open the door. But we need code for the door to be able to do that, so we're gonna make this very, very simple. Go to your event graph, delete all of this, and right click, and we're gonna type in the word custom, press enter for a custom event. Remember, an event is something that happened, so now we're gonna fire some code, and we're just gonna go ahead and name this open door, no spaces, capitalization on open and door. We're gonna pull out of open door, and we're gonna type in move component, and we're gonna look for move component 2. In this case, the component is going to be the SM door, so pull out the SM door from your components list, plug that into the component. And you'll remember that the default location is 0, 0, 0, and if you click on SM door, it will appear on this right-hand side as well. See, default 0, 0, 0, 0, 0, 0. This is important because if you make a door this way and you need to move the door around, you need to mimic that location, or it's gonna move back to its default 0, 0, 0, which isn't what you want. Let's head back to the viewport and actually rotate it to the open position, and you can see that the open position is just positive 90. If you get that 8999999, it's 90. So we'll go ahead and put that back at 0. Go to the event graph, and we just need to make the Z rotation 90. I like doors to ease in and out. Basically, that means instead of a very, very consistent speed of just when the door opens, I don't even know if you can see my hand. So like, see how it's very consistent? Ease in, accelerates, and then slows down. And that's what I like for doors. I think that looks really good. Ease in and out basically means accelerate, de-accelerate. Towards the beginning, towards the end. Over time, it's a door. 1 second is fine. And for now, that's all we're gonna do. We're gonna hit save and compile because we only need the functionality of the door opening. I'm not gonna do anything else. We'll come back to this in a little bit. Nothing can call this event, of course, because there's no such thing as an open door event. We created that, so we need to be able to call it, but we'll get to that. Just so you know, we can now delete the static mesh off of our AI stage, and we can actually drag in the blueprint we created, which you'll see that it is the blueprint. 1, because it's got the little blueprint logo, but 2, we now have the box collision as well. And we'll move this kind of close to our AI, so that way, whenever it does move, we have a pretty high chance of the AI actually touching the door, or rather, at least the box collision of the door. However, if we head back into our behavior tree, so let me pull that up real quick, you'll note that we get random location, we move to, and we wait. We never actually open the door. So how do we get the AI to open the door? Well, right now, the AI can't make any decisions. Remember how I said the Blackboard is how it makes decisions, and in this case, the only decision it can make is the target location. Well, let's create a Boolean, which is a true or false value, and we will name that Boolean near door. So now we're gonna have a Boolean that says near door, but how do we get the tree to be able to make the decision to open that door? Well, we need an additional node between the root and this sequence, a selector. A selector, think of the selector as, hey, I'm a choice that needs to be made. So let's go ahead and plug the selector into this sequence, and then we'll create the new sequence to open the door. In order to do that, we're gonna need 2 new files. Don't hold me on that, I think it's 2. But what we need to do is up here is click on new task, and we're gonna click on the blueprint base. We're gonna put that, of course, in the tasks folder. We're gonna leave btt task _ and we're going to rename this open door and press save. Now this isn't gonna work yet, and I'm gonna show you the issue that we're going to come across. But for now, if you remember, we need an event execute. So we're gonna type in event execute, and we specifically want the AI version. This is when the tree says, hey, do a thing. This is what gets called. So now that we have our event, we need to tell the door to open, but how do we access that door? Because it could be any door, right? We can't specifically say the door on the platform, because what if we want this AI to work on multiple levels, or just multiple levels that have hundreds of doors? We don't want to set up code that hardwires to each specific door. That'd be very inefficient, and it'd be very hard to use. So we need to know what door it's near. Believe it or not, if you look here, we have controlled pawn. We can have the pawn let us know that it is near a door. So what we're going to do, if you remember, the pawn is the actual character, so the BP AI tutorial. We're gonna create a variable, and we are going to call this local door. And basically that just means the one that we're near. And I'm gonna change the variable type to BP _ door 1. I want to give you a quick warning about how we created the door. If you're new, this is valuable information. It's gold, okay? We are hardwiring this variable to go to door 1, because as of right now, if you had multiple doors, as you can see, it's only looking for BP door 1. You can see where that would be an issue if you had multiple types of doors. The way around this is create a parent door. And I know for some of you that's gonna sound like Spanish. So if that doesn't make sense to you, look in to how the parent to child relationship works. because if we had a parent door, essentially it would be a blueprint that contains all the variables for a door, but doesn't include things like the static mesh or how far it rotates and things like that. So therefore, every door we create as a child to that first parent door, the engine can assume that it will have those variables because they're inherited from the parent. Again, if that sounds like Spanish, please learn about parent-to-child relationships. I'm not going to do it here because it would extend the duration of this video significantly. Let's continue. So what we're going to do is we're actually going to create a custom event. And what that custom event is going to be is update local door. And it's going to do exactly like the name says. It's going to set the local door. However, in order for that to happen, we're going to require an input. So an input on the right-hand side here, hit this plus. What an input is, if you look at the event, you'll see that the new parameter is there. What it is it's saying, hey, in order for this function, this event to run, I need additional information or I can't run. And you'll see where that is going to be useful later. For now, I'm going to just name this door, and I'm going to update the variable type to BP door 1 as an object reference, and I'm going to hit save and compile. Then all I'm simply going to do is drag local door out, press set. I'm going to plug in both of these straight across like that, create a comment, update which door we're near. In fact, I'm gonna make that a little more detailed by setting the local door variable, just like that. And then we're actually going to clear that variable as well. So we're gonna create another custom event. We're gonna call it clear local door. And this one's a lot more simple because we're not going to need to plug anything in except for pull this out, set local door, and this time don't put anything here. We're gonna go ahead and make a comment and just say clear the local door by setting the local door variable to nothing. So essentially what's gonna happen is whenever we call update local door, it's gonna say, hey, we're near a door. But then whenever we get too far away, we're going to then clear that variable. So that way, if we run some code that tries to access the local door, it doesn't open a door that's really far away because the code still has access to that as being the last door we were near, if that makes sense. Save and compile. So believe it or not, we're actually not going to call these functions or events near or from this character. We're actually going to call them from the door. The door is the thing that has the collision that says, hey, I need to let you know that I'm near you. It's actually not the AI, but the door. So what we're gonna do is we're gonna head back to our door blueprint. And now what we're gonna do, because you remember we have the one thing here that opens the door, we're gonna use that box collision to our advantage. We're gonna right click on it and we're gonna click add event. Remember, event is red. It's the thing that happens to cause code to fire. And what we're gonna do is we're going to on component begin overlap, okay? And we're gonna drag that down so we have some space. The first thing we need to do is make sure the other actor, this is the thing that is now overlapping the box collision. We need to make sure that thing is the AI. So in order to do that, from other actor, we're gonna drag out and we're gonna type in the word cast, and we're gonna type in cast to BP AI tutorial. So what's gonna happen is when we overlap, it's gonna say, hey, is this the AI? If it's not, the cast fail node will fire. However, if it is the top here, this successful node will fire instead, which is perfect. If you're new, a quick warning about casting. Casting can be used, a lot of people will tell you you shouldn't. It can be used in limited quantities. Do not cast very often, but the occasional cast is okay. I'm not gonna go into details to why right now, just know that casting is okay in moderation. So once we begin overlap, we're gonna make sure it's the AI tutorial, and then if it is, we're actually gonna pull out of the ABP AI tutorial because now we have access to its functions if we pull out from there. And we're gonna type in update local door, Now you're gonna see why the input was important. See how we required an input? Well, on this function we just called, which is specifically this right here, you'll note that now it's requiring that we input a door here in order for this to run. So we're just gonna pull out, and since this is the door, we're just gonna type in the word self. And now what's gonna happen is when we overlap, we are going to make sure it is the AI. And if it is, tell the AI that we are near it. We are gonna update that variable. Hey, we're near you. Grab it, comment, tell the well, you know what, let's do the full thing. Make sure the AI is what is overlapping us, then tell the AI that we're near it. Now we're gonna do the exact opposite. So if you right click on box, go to add event, there's come on component end overlap. So this is gonna be roughly exactly the same code. We're gonna do a cast. So we can go ahead and copy and paste the cast down here like that. The other actor, of course, goes into the object. But instead of updating the local door, instead what we're going to do is we are going to clear the local door, which, as you remember, is saying, hey, you're no longer near me, so get rid of that variable. I don't want to be there anymore. We'll grab that, comment, make sure the AI is what is leaving, then clear the door if it is. Save and compile. So we just did like 5 things gonna have to communicate with each other. So let's go over what just happened really quickly. AI gets close to the door. We make sure that it's the AI, update the local door. AI goes too far away, clear the local door. Boom. If we update the local door, we're updating this variable in the AI, the pawn, if you remember to be more specific, and we are clearing the door if the pawn is no longer close enough. So now we need to let the AI controller let the behavior tree know that, hey, just so you know, local door has a variable, and then the behavior tree can go, oh, well then we need to open it. And the best way to go about this are things called blueprint interfaces. And in fact, once you become a master of blueprint interfaces, you'll be able to pretty much stop casting in almost all scenarios. Casting is still relevant in some scenarios, but interfaces reduces that by a lot. So I'm actually gonna go ahead and I'm gonna create a new folder, and I'm gonna call this BP underscore interfaces. Now I tend to have several BP interfaces folders, because this is going to be specifically for AI, because interfaces are useful for so many things. But regardless, what we're going to do is we're in that folder, we're going to go up to blueprints, not blueprint class, but blueprints, and you'll see that there is a blueprint interface. I'm going to go ahead and name this interface underscore near door, just like that. And I'm going to open it up, and you'll see that we have a new function, and there's basically nothing there relevant, but we can change that. On the right hand side, I'm going to click on new function, I'm going to press F2, and I'm going to name this update near door, because remember, we're going to be updating that variable. So we're going to update near door, and we're actually going to require an input. And that's basically all we have to do. I'm going to hit save and compile, and now whenever we apply this to our blueprints, we'll be able to call it in the engine. And I know that sounds confusing, but don't worry, it is not. So the first thing we need to apply it to is our pawn. So up here in the class settings, go over to the right hand side, and you're going to see that we have implemented interfaces. Go ahead and click the down arrow and start typing in the name of whatever you called it. I named mine interface underscore, and you'll see that near door then pops up. I'm going to click on it, and then I'm going to save and compile. So there's one last step that we need to do whenever we update the local door. Anytime update local door happens, we need to call this interface. Now you can't just drag it over. That's not how they work. What we're going to do is pull out of the set, and we're going to start typing in update near door. Now you'll see there's multiple here. There's call function. There's one that just says class update near door, and there's one that says message. In this case, we need the message. So what the message does is it goes to any blueprint that is implementing that specific interface, and it says, hey, I'm giving you a message that we're doing something because the interface. That's all it knows, but that's all it needs to know. And I'll explain why when we get there. However, you'll note that it needs a target. So I'm going to drag this down, so I can expand my comment ever so slightly. And the target is, what we're gonna do is we're gonna right click and I'm gonna type in get AI controller. So we're gonna click on this one, and out of the controlled actor, we're gonna type in the word self, because we are the pawn. We are the thing that's being controlled. We're just trying to get our AI controller. And you're gonna plug that into the target. Now, as I said, what's gonna happen is it's gonna update the local door, and then we're gonna update that fact in the AI controller, okay? And in order to do that, remember we're using Blueprint interface. So let's head to the AI controller. As of right now, it doesn't have the interface. You can send that message to anything, but make sure you eventually add the interface or it just won't work. So in the class settings, what we're gonna do, same thing. We're gonna go down to the implemented interfaces. I'm gonna type in interface underscore near, like that. So now that it is implemented, we're gonna save and compile. And what we're gonna do now is I'm gonna right click and I'm gonna again type in interface near door. Now, I'm gonna right click and I'm just gonna type in, update near door. And now you'll see we have event update near door. What have I said 100 times? Events are red. There's something that happens to run some code. This is red and it's an event. So what's happening? Well, when the pawn sends the message, hey, your interface is firing, this event fires. So you can see how this is now having two separate blueprints communicate with each other. This is something that is very difficult for new people to understand how to get to work, and I'm hoping this helps. So the reason we had to send it to the AI controller before the tree is because accessing the tree is pretty much something only the AI controller can do. You can do it in other blueprints, but I don't recommend it. It's just unclean code and it causes all kinds of issues and can get very complex very quickly. So just send it to the controller if it needs to affect the tree. So now we're gonna update near door. I'm actually gonna create a variable and I'm just gonna call it near door. It can stay a Boolean, it's fine. And whenever we update near door, I'm gonna go ahead and pull this over and I'm gonna go ahead and type I'm gonna pull over and get set. And we're gonna pull out and we're gonna just check this to true. So now the AI controller is aware that it's true, so we set it to true. In fact, to optimize our code, I'm gonna show you something that I should have done. We're gonna go back to the interface. So go ahead and reopen your interface if you closed it. We're going to require an input, so select plus on the input and just type in near door and leave it a Boolean and hit save and compile. So the reason I did that is now it requires an input. So the reason that was beneficial is if we head back to the pawn, the thing that's calling this, instead of us having this code twice, instead of having an additional function, one that makes it true and one that makes it false, we now have one function that can do both. So if we simply grab all three of these, copy and paste, we can drag that in like that. This one will make it false if we clear. This one will make it true if we set a door. We set a door. In the AI controller, that Boolean is now true. If we clear a door in the AI controller, that Boolean is now false. So in the AI controller, this function is now doing both, which is why requiring the input there was a plus. So great, it's set in the AI controller now, but it's not set in the behavior tree. So the behavior tree can never do whatever we're gonna add because it's not set. So we need to make it so the AI controller will now update the behavior tree as well. The good thing about the AI controller is if we right click in the event graph and we type in get Blackboard, you'll see that there's two. We want the one that has the little blue mark next to it. This is our Blackboard. And what's great is we can pull out of the Blackboard and type in set value as Boolean, because remember, we're gonna be updating a Boolean. We can plug that in and look, Boolean value. Well, our function already does this, so we can plug that straight in, right in. However, we need a key name. Now, what is the key name? Well, let's head to the Blackboard, and you'll remember we created a Boolean called near door. So, how do we set key name? If we pull out of key name, what you need to do is type in make literal, okay? And you're gonna get make literal name. This name is going to be the exact name, oh, near deer, no. The exact name as the key in the Blackboard. Spelling, capitalization, exactly the same. So we're gonna hit save and compile. So remember, this is all chained together. The door sees that we overlap it and it says update the local door. The pawn sets local door as a variable, and then it says, hey, update that we're near a door in the AI controller. The AI controller then goes, oh, yes, we are near a door. Tell the behavior tree. More like tell the Blackboard, but tell the behavior tree that we are indeed near a door. Is it convoluted? Yes, but unfortunately when you have this many systems talking to each other, it is a little convoluted. It just is what it is. So the Blackboard will now have that set. So now the behavior tree can make a decision. We're gonna pull out of the selector and we need another sequence, okay? However, how does it choose between this one and this one? It's called a decorator. Right click on the right hand side. And what you're gonna do is you're going to add a decorator, a Blackboard decorator, and you've got this blue box now. If you click the blue box, you'll see that we have something about aborting. We also have a key query and a Blackboard key. Well, we want to do the Blackboard key as near door, and specifically is set, or in this case is a Boolean. Is set is basically true, and then is not set would be false. So near door is set. So the selector is gonna say, whoa, wait a minute. Near door is set. I'm gonna choose this option. But just run with me on this because I slightly did it out of order. I apologize. We also need a decorator here as well. We need to add a decorator, and we need to create a Blackboard decorator. We're gonna click on the blue part, and this time we want near door is not set. So check it out. Very easy decision for it to make. Are we near a door? No. Okay, well, I'm gonna keep running around randomly. Are we near a door? We are. Interesting. Okay, well, then I'm gonna open the door. However, what if it already decided that it's not near a door? Will it just immediately leave this sequence to go over to here? The answer lies in, if you go ahead and click on your condition here, it lies in on whether or not it aborts. See how it says none? If it is out of the range of the door, because it never aborts, it will run this sequence endlessly. So what we need to do is we need to change observer aborts to both. What does that mean? This is actually a little complicated, and even I still get it a little confused sometimes, but I will give you a brief rundown. None means it will never abort, no matter what. It needs to finish what it's doing, and then it might leave that decision, okay? Self basically means I will quit doing what I'm doing if my condition becomes not true. Because as you can see right now, the only condition here is near door is not set. So if that isn't true anymore, I'm going to abort what I'm doing. Lower priority. So how does priority work? By default, without changing anything, priority is left to right, top, and then top down. You can tell by the numbers. This is number 1, highest priority. This is number 2, second priority. 3, 4, 5. See, top left to bottom right. If we go this way, 6 and 7, okay? And that is their priority. Well, if we select lower priority, it's saying if my condition is no longer true, everything that's lower priority than me is going to be abandoned. And remember, 1 being the highest priority, higher numbers being a lower priority. So in this case, if we had lower priority selected, basically nothing would happen because it would abort this, but near door is a lower priority, so it would abort that as well. Now, it would eventually go back to the root and then go down to the actual near door set, because it would have to choose again between which route to go. Does that make sense? But we don't need to use lower priority because we don't need to abort this whenever that's actually what we're going to be doing. So in this case, we're going to click self, okay? It only needs to abort this right here whenever the condition changes to not true. And then there's both. Both basically means, hey, when my condition changes, everything aborts and the tree goes back to the top and then runs back down, okay? In this case, we just need self, okay? Abort self when the condition fails, because it's gonna go back to the root, it's gonna go to the selector, and it's gonna say, oh, hey, we're near a door, we're gonna go this way. So we were working on a task to open the door. However, we're gonna need another interface, because we have an interface, if you remember, that updates that we're near a door. However, now we need an interface, so we're gonna right click, blueprint interface. I'm gonna name mine interface underscore open door. And all we're gonna do with this one is we're not gonna require an input, I don't think, on this one. We're just gonna change the name to open door. In fact, to be more specific, I'm gonna name it interface open door. And the only reason I'm doing that is because it's a very common thing to name a function open door. So this just separates it as, hey, this is specifically the interface saying open door. And within our task, we are going to say, whatever the pawn is that we're controlling, we've received notification that you're near a door. So what we're gonna have you do is interface open door interface open door. You'll notice that the task doesn't require the interface. At least I don't think it does. If it fails, we'll know why. And then we simply pull out, and now what we do is we want to finish the execute, because remember, it starts with the execute and then it finishes the execute with a success. So we're gonna hit save and compile. And what we're gonna do is, out of this sequence, we are simply gonna run the task of open door. What's gonna happen, if you think about it, is we're gonna get near a door, it's gonna open, then we're never gonna move again. Why? Because near door never changes back to not being set. So we need to make it so whenever our pawn does open the door, which I will show you how we're gonna do that actually. Let's go to class settings. Let's implement the interface underscore open door. Save and compile. We're gonna right click. We're gonna type in open door. And in this case, we want the event interface open door. Remember, this is what is called when the message is received. We're gonna get whatever our door is that we have saved as the local door. And we are going to run that code that we did in the very beginning called open door. So there's a lot of things communicating here. And I know this is probably a bit complicated to new people, but if you have specific questions, don't be scared to ask me. So we call the door to be open. So then what we're gonna do is immediately clear the local door. The reason for that is no matter what, we won't update the local door again unless we leave the door and came back to it anyway. So that being said, we can clear the local door the second we open it, which then of course is gonna go to the AI controller, which is then gonna go to the behavior tree, and then it now knows it can go back to just randomly walking. around. So in theory, this is now all connected and should work. So let's head over to our example and see if the door gets opened. So I'm gonna hit play and I'm gonna look at my AI and notice that it's not moving at all. So let me figure out what that's all about. Okay, I'm not sure why it did that, but the AI is now moving around now. So let's wait and patiently see when it decides to finally go near the door. All right, so there we go. It got near the door. It updated that variable. It told the AI controller. The AI controller told the behavior tree, and the behavior tree said, whoa, 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 we're near a door. So think about this as like the eyes telling the brain, telling the arm. It has to go through several different parts to get there. And that's why this is so complicated and why I chose to choose something outside of the pawn's direct control, because we have to have a lot of parts communicate with each other. This is a very difficult topic for new Unreal Engine developers. So if you are lost, confused, and just exhausted, that's normal. Don't be beaten up. This is normal. Rewatch the video if you have to. Lots of parts are communicating with each other. I made it as simple as I could. I hope you guys are enjoying the series. I want to do more of these. Like, comment, subscribe, and I'll see you in the next episode. Today's Indie Ally shout out goes to Frazier with the art that he's been working on, saying, making a kinda overworld style selector, some preliminary art concepts. Here's another where he's trying to base it off the Museum of Auckland. If you'd like a chance to be at the end of one of my videos and have your work shouted out, head over to the Indie Allies Discord, link in the description.